Okay, goal 5.3 is on simplifying complex fractions. A complex fraction is simply a fraction within a fraction. You actually can go as deep as within a fraction. But that's just what makes it a complex fraction. Okay? Simplifying, not necessarily this first one, but the ones I'm going to do after that, is kind of a combination of goal 5.2, because you have to think adding and subtracting first, and then go back to goal 5.1, which was simplifying, multiplying, dividing. So it's kind of it's a combination of doing the things that we did in both of those goals. Okay? You should have a main fraction bar. So in this particular one, this is like my main fraction bar. And I have x over y squared divided by then x over y. And when you are dividing by a fraction, whether it's written like this, which you haven't seen yet, or with a division symbol, which you have seen, okay, the rule is to reciprocate the fraction you're dividing by and to multiply. So this question turns into the numerator stays the same and the denominator gets flipped. Because this is the same thing as writing this. This is the same thing as writing it like that. It's just written a different way, making it a complex fraction. Okay? So same kind of question. So if it makes it easier for you to rewrite it with the division symbol, then you can rewrite it with the division symbol and then proceed from there. Okay? So I'm not going to do that, but you could do that. So I have a fraction divided by a fraction, so I'm going to reciprocate my second fraction, and I'm going to simplify that. So when I simplify, my x's cancel, my y cancels with one of those, leaving me 1 over y. Now that one's a simple one because it started out as a fraction over a fraction. We didn't have to do any pre-work to get it that way. Now we'll get a little more complicated here. There are two different ways to approach these questions. I know that Mrs. Stephens and myself, and I think Mr. Pelster do it one way and Mr. Pelster, yeah, do it one way, and I think Mrs. Pelster does it a different way. I personally think it's simpler, even though it might sometimes require a little more work, that you make a single fraction in the numerator, and then you make a single fraction in the denominator, and then we do our flipping, okay? It's possible to make a single common denominator for the whole problem, but that mathematically is harder to understand, so I don't do it that way. I do it so that it kind of really pulls goals 5.1 and 5.2 together, okay? So start off by looking at just the numerator. So we're going to make the numerator. We're not even looking at this down here, okay? So we're going to make the numerator a single fraction. Right now it's a fraction plus a whole number. We're going to make it a single fraction. So in the numerator, my common denominator is y. So the first term has that denominator, which means it needs nothing. The second term doesn't even have a denominator. It's understood to be over 1, so that means it needs the denominator. So this is just like our adding and subtracting part. So x comes over plus 2 times y, 2y. Then I go to my denominator, and I do the same thing. So I ignore the numerator now, and I just do this piece. So the common denominator in the denominator is y. The first term, which doesn't even have a denominator, understood 1, needs the y. And the second denominator looks just like it, so it doesn't need anything. So I end up with 1 times y is y minus x. So your goal, using addition and subtraction rules like you did today, is to make it a single fraction divided by a single fraction. once you do that, then it turns into what we did in Goal 5.1. We have a division of fractions here. Oops, not that, it's going to equal. So our numerator is going to stay the same. Our denominator is going to flip, reciprocate. We're going to factor if we can, but none of those positions or places, numerators, denominators, factor. So then we're going to reduce if we can, and those will cancel, leaving me x plus 2y over y minus x. So again, from the beginning of the question, if you don't like it written like this, you can take the numerator, write a division symbol, and then the denominator, and then proceed the same way though. Okay, again, numerator first, then denominator, then we'll flip. So in the numerator, my LCD is the quantity or group x plus 3. That's the only denominator there, so it has to be the LCD. The first term, which has no denominator, understood to be a 1, then needs that x plus 3. The second denominator doesn't need it because it has the LCD already. So I multiply through and I get x times x times 3, and then plus 2. Over the common denominator of the denominator is x minus 3. So again, I know it looks different, but you're just doing addition, subtraction like you did today. So common denominator is x minus 3. So first term doesn't have a denominator, understood 1, so it needs the x minus 3. Second one has the LCD already, so it needs nothing. So I multiply through and get x to the second minus 3x. And then my minus 4 comes over. So use addition, subtraction to get it written as a single fraction over a single fraction. Then it turns into what we did in Goal 5.1, where we're just going to factor and reduce. So my numerator, which doesn't flip, I'm going to go ahead and factor it. I'm going to save myself writing another step. So this numerator is going to factor, so I'm going to go ahead and factor it. X plus 2, x plus 1. Over x plus 3. This one's going to flip. So my x minus 3 is going to come up. And I'm going to factor the x squared minus 3x minus 4 into x minus 4, x plus 1. And then I'm going to cancel. Only one little thing to cancel here, my x plus 1s. X plus 3, x minus 3, not inverses. So everything left, put together, not multiplied out though, is my answer. Okay, and my last one. In my numerator, The common denominator is x squared. So the first denominator, which says x, needs to be x squared, so it needs another x. The second denominator looks exactly like the LCD, so it needs nothing. So I'm going to multiply through 2 times x plus 3 over the LCD, and the denominator is x. So the first term, which does not have a denominator, understood 1, needs the x. The second denominator looks exactly like the LCD, so it doesn't need anything. So I multiply through and get 4x times x, 4x squared, and minus 9 comes over. So once I get it written as my single fraction over my single fraction, then I'm ready to flip it, factors, reduce, whatever. So the numerator one stays the same. There's no factoring to do. The denominator is now going to flip. So the x is going to come up to the top. 4x squared minus 9, which factors? It is a difference of squares. Comes to the denominator. And I cancel. Reduce. Whole group with the whole group. 2x plus 3 with 2x plus 3. The x on the top with one of those on the bottom. Everything left is in the denominator. It's got to stay there, which means I just have an understood 1 in my numerator. So you can see it's a combination. First you're using your addition and subtraction rules. Once it's your single fraction over your single fraction, then you're doing what you did in Goal 5.1, where you're factoring, canceling. Factoring, canceling. Okay? Okay, you have 5 questions for your OTL. We will assess on this Wednesday. That assessment will have 2 questions on it. Short, sweet.
2 questions?
2.
They should have got one wrong.